Okay, now we want to talk about the projection of A on B and how you calculate it. It's fairly simple. The scheme is fairly simple. And I don't particularly like what I did down here, so I'm going to refer to this picture up here. Okay. Now, if this angle is theta, then the length of this side is what? It's the magnitude of A, because this vector has length, magnitude of A, multiplied by the cosine of this angle. Okay, so this side here, if we redraw the figure, this side here will have length, magnitude of A, cosine theta. Okay, that will be the length of this side. Now, it's supposed to be right angle. I don't think I did a very good job of that. But the magnitude of this projection then is the length of this side. Now, the vector projection is a vector. It has a length equal to the length of this side and goes in the direction of the unit vector. Unit vector in the direction of V. Now, that's not quite right, but as it will turn out, because of course A could be down this way, so the projection you'd have to extend the figure out here, and the projection be in the direction opposite V. In that case, when you calculate magnitude of A cosine theta, you get a negative. So this really isn't the length of this side in every case. It's only the length of this side if the projection goes in the direction of V. If it doesn't go in the direction of V, then this is going to be negative because theta is going to be more than 90 degrees, and this is going to be a negative quantity. Well, the bottom line there is that the projection is, vector projection is the magnitude of A cosine theta multiplied by a unit vector in the direction of V. The unit vector in the direction of V. And the unit vector is just the V vector, as we know, divided by the magnitude of the V vector. Now, I hope you can read that. It's not written as clearly as I'd like, but it's kind of repeated over here. So the magnitude of the projection is the magnitude of A cosine theta, and that is the length of this side. Okay, so, and that's the magnitude of A dotted with a unit vector. The unit vector, turns out. And reason for that we'll talk about in a minute. So the projection, scalar projection, is magnitude of A cosine theta. That's this thing. We multiply that by the unit vector V over magnitude of V, and we have the vector projection. So we kind of have a formula, but we need to understand the details. The formula says we have the scalar projection A dot the unit vector V over magnitude V. And then to get the vector projection, we multiply that scalar projection by the unit vector in the direction of V. And now we want to see, okay, well, how do we find A parallel and A perpendicular for given R of T vector? And that's what we're going to go ahead and do. Okay, there are better explanations. I've given more detailed explanations of the projection elsewhere. So if you have trouble with that, holler at me and I'll connect you up with one of those videos, or just look up a video on projection. Now, the one thing you'll see, and I don't like, you could actually combine these and get A dot V multiplied by V over magnitude of V squared, because of course we have magnitude of V twice here. In my opinion, that obscures the meaning of this thing as this quantity, which is your scalar projection, times this quantity, which is your unit vector, and you lose the geometric interpretation. So make sure you completely understand this before you start combining this into a magnitude of V squared, because that's a formula you're probably going to see if you look at anything but my stuff, if you look at your book, etc. Your book will develop all this, but won't emphasize this. And I think it's a great book. I don't necessarily argue against that, but this is what I really pretty strongly advocate. You understand the meaning. This shows you the meaning. The other just gives you a formula, and you replace meaning with a formula, and then you're less able to apply the entire idea. You can calculate it if you're given everything you need, but it's harder to remember the formula, and you're less powerful in your application if you don't understand things at a little deeper level.